So as you look at example 1, you need to notice then that they have to give us two different functions. And in this case, they've given us the rule for two different functions. They gave us the rule for the function f, and they gave us the rule for the function g. So now that we have the directions for example 1, suppose that f of x equals x squared and g of x equals 3x minus 1, we're ready to do a variety of different things with those. So part A, it asks us to find f composed with g. Now, as you look at this and you compare it to our definition from a moment ago, f composed with g, when they write it in the directions here, you're going to notice that it doesn't have an x, but the definition has an x. So the very first thing you have to realize is they're just saying, oh, okay, we're just asking you to figure out the rule for this new function called f composed with g, and in order to have a rule, we have to have that x. So your very first step is to simply slide an x in behind this piece that they gave us, the name of the function f composed with g. So we have f composed with g of x. Now that we know that that's the first step of the problem, the second step of the problem is to use our definition. We know that f composed with g of x is in fact f of g of x. So now as I look at this problem, I have layer upon layer of parentheses. And if you think about the order of operations, when you have multiple layers of parentheses, you start on the inside and you work your way out. And we do the same thing here in the world of functional composition. So as I start on the inside then, I notice that I have a g of x sitting there. Well, I have a g of x up here too. G of x and 3x minus 1 are the same thing. 3x minus 1 is the rule for my function g of x. So what I can do is replace g of x with its rule, 3x minus 1. But now that I've done that, notice that we still have that f on the outside. So this is now a functional notation problem. We have f of somebody. Well, I have a rule for f of anybody. F of anybody, I take that anybody and I square it. So when I look at this particular problem, what's happening is that we have a substitution. And I'm replacing this x on both the left and the right by 3x minus 1. So once again, f of anybody is going to be anybody squared. Well, in this case, we have 3x minus 1. So f of 3x minus 1 is going to be the quantity 3x minus 1 squared. Well, now that we have this then, we can go ahead and remember that 3x minus 1 quantity squared is going to be the same thing as 3x minus 1 times 3x minus 1. And as I've said multiple times throughout the semester, you've got to remember then that anytime you have a quantity like this squared, it's going to be a FOIL problem. So if you looked at this and you didn't see that as a FOIL problem, make sure you make a big old note to yourself one more time to say, 3x minus 1 quantity squared. I can't simply square the 3x and square the 1 and expect to get the right answer. I'm going to actually FOIL that out. So if I FOIL this out then, 3x times 3x is going to give me 9x squared. Outer two terms will give me a negative 3x. The inner two terms will give me a negative 3x. So that comes together as a negative 6x. And then the last terms, negative 1 times negative 1 will give me a positive 1. So what we have now done then is found a rule for this new function f composed with g. F composed with g takes any x value and gives you back 9x squared minus 6x plus 1.